Aggregation. Okay, sure. That's a good one. Let me present my screen. Before we do that, let me just close stuff. Okay. So aggregation. So we have this class aggregate that has two parameters, arg and expr. So arg is what kind of argument this aggregate function takes, and expr is what kind of expression it returns. And there's a functional dependency, which means that we can infer what kind of argument is taken by what kind of function we're returning, right? So the reason we have a class is because this class has, and you see the functions, average, min, max, sum, all the usual aggregate functions, is that we have two instances, one for grouped expressions, and these are the aggregates you're used to, and one for window functions. So these are less commonly used, but the same aggregate functions also work as window functions, although there are some window functions that don't work, vice versa. So all aggregate functions are window functions, but not all window functions are aggregate functions. So in the case of just a normal aggregate, which is an expression where you have some grouped columns, right? For that case, your argument is a so-called aggregate arg, which has the arguments themselves, any ordering that you might want to put on the arguments, and any filtering that you might want to put on the arguments. So this is really useful when you're doing like array aggregation, because sometimes you care about the ordering of the array that you're getting back. And so you can go ahead and order it. And the filter is very useful because you can do things like filter out nulls, which is most of the time what you're going to be filtering. And we can either aggregate everything or just the distinct rows, right? And we have some combinators. So all lets you have a single expression. You say all that, and then that gives you an aggregate arg, which has a single argument. Or you can use alls plural if it's a multi-argument function, like, for instance, what's some examples? The regression XX has two arguments, right? So that's something you would use alls for. And then same for distincts and distincts. And then all not null here actually goes ahead and applies a filter. So if we look at the source for all not null, it goes ahead and filters null or not null, filters out null values of X. And then it knows that since they're all filtered out, we can just tag this with an unsafe not null, and then we get the type that we want. It turns a null into a not null. Okay. And filter where is, we have two examples. We have aggregate args and window args. So you can filter the arguments of a window function, and you can filter the arguments of an aggregate function.
Hey, Tom, do you mind hopping off of VPN again?
Yeah. So let's see some examples, because there's examples here in the docs. Count star is a very obvious one, doesn't take any arguments. Count, you have to give it an aggregate argument, which would be like all of some column. Here's an example with a filter. So you can modify, and you can keep chaining these, and it'll just AND them together. And you can also do order by. So here's an example of a array ag where we're doing an order by and a filter where. What's some examples of some window? Here's a window function, right? So instead of using all, you'll use window. Okay.
And can you briefly explain in SQL what a window means?
Yeah. So in your select list, you can say, okay, I want to get back. I want to look at windows over my table, my intermediate table, and I want to get back, say, just for everything in that window, I want to get back like the first thing in that window. Let's look at the docs because maybe that'll explain it better. So set of table rows that are somehow related to the current row. So if you're looking at your current row, you want to look sort of around it and do something, aggregate the rows that are around it.
Around in the same table?
Yeah, in the same intermediate table, yeah. So here's an example. Select department name, employee number, salary, average salary over partition by department from the employee salary table. So here's the window function, or the window expression, I should say. Here's the window function. Here's the window argument. And here's the partition by clause, okay? So what we're going to do is we look in the employee salary table that looks like this, I guess. And we are partitioning by department name. So it sort of groups these together, just like group by does. But then when it returns, it's going to say, okay, so this row is related to this row, is related to this row, is related to this row. So for all of them, and this one, so for all of them, return the average of all of them. Okay, that makes sense?
Okay, thank you.
And so you can do these window functions in Squeal too, and I can show you how to do that. In fact, we can see that in select. If we look at selections, we have this over. And so we can say, give me a list of window functions over a window definition. And we can construct a window definition using partition by. And you can also order it. So you can order your, do an ordering on that. Okay. So that's window functions and aggregate functions. Any questions about those? Let's go back to aggregate here. So I said, again, there was an example we said of two variables. So here you see we use the plural alls because covariance of the population takes two arguments. The other thing is when you're doing aggregation, you need to understand grouping. So let's go to grouping. That would be in query, probably table. Yeah. So a table expression has a group by clause. And a group by clause has two type parameters, group and from. Okay. The group indicates a grouping. So either aggregation, no aggregation is permitted if we're ungrouped, if our expression if our query is ungrouped, or we have aggregation required for any column which is not grouped. So when we say group, these are the things that we are grouping by, and anything that's not in here can only be called if it's called inside of an aggregate function, right? So this is a normal restriction in SQL. If I don't group by a given column, then I can't call that column unless I call it inside of an aggregate function. And this is what type checks that, this grouping structure. Okay. And we can see also having does a filter on your grouping. So if we look for the group by function, this function here says, okay, give me a list of columns to group by, and I will transform your table expression from being ungrouped to being grouped. And there's sort of one important thing about this, which is that if you're doing, you know, what's called a grand total aggregation. So I want to sum all the rows in a table. In SQL, you would just say sum of all the rows in the table, right? But in Squeal, you have to say that it's grouped, because otherwise it won't know that you can even do an aggregation, right? So for Squeal, you use group by nil to perform a grand total. There's a couple gotchas with grouping. So one small gotcha is that in SQL, you can group by any sort of expression. So you can group by like column 1 plus column 2. And in Squeal, because I want to hold on to those names that are grouped, I make it so that you can only really group by columns. So you say group by this column that's in your from clause. So that's a little bit more restrictive than SQL. And then also in SQL, if you group by a primary key, then it also groups by every other column that was in that table for which that's the primary key, right? So those are called functionally dependent because they're functionally dependent on the primary key. If the primary key is unique, then they're, you know, you get, so you just get a single row is a group, basically, if you're grouping by primary key. And Squeal doesn't know how to do that because it doesn't like keep that information around that that's the primary key after you've, you know, used it in a from clause. That's a slight gotcha with Squeal grouping, but it's still pretty good. We're running a little bit out of material. What else haven't we gone over? What about ranges? Do you guys use ranges?
No, what's a range?
A range is like a time range or a number range. It's an interval. Same thing as an interval. It's a connected subset of the real line. So Postgres has a type for ranges. You can see here in our types, we have int4 range, int8 range, num range, timestamp range, timestamp with time zone range, date range. And so we can handle that on the Haskell side with this range type. A range type is either empty or it's non-empty with a lower bound and an upper bound. And a bound is either that it's closed, so it includes the bound. It's open, so it doesn't include the bound, or it's infinite, so it's unbounded. And we can construct ranges in all sorts of different ways. We can say, okay, I want the range that's between the lower bound and the upper bound inclusive, right? So we make an operator for that. And similarly, we make operators for all these finite range constructors. And then we have sort of half infinite range constructors. So we can be more than X or at least X, or we can be less than X or at most X. And so less than is the strict inequality, and at most is the weak inequality. And we can have a singleton range or the whole line. And then we have operators in Postgres land. So here I can say range, give it a type, and then give it a range of expressions, and that'll inline to be, so if I say range, timestamp time zone range, at least now, it'll input this timestamp time zone range from now until null. The null is because we have no upper bound. And then a little string that indicates whether the lower bound is closed or open, and not the same for the upper bound. And then we have all these operators that you can use to test overlapping of ranges and containing of ranges and so forth. Merging of ranges. Okay, let's look at JSON, because there's a lot of JSON. Postgres has a lot of support for JSON, and Squeal offers the same sort of support, although it puts a little dot in front of the operators. So if you're used to these operators from SQL, they're available here. And these let you do things like go into a JSON object, like, go into the leaves of it, do a path, and lets you convert, and lets you convert arrays to JSON and composites to JSON. All sorts of different ways of building JSON. Yeah, tons and tons of JSON functions, as you can see. Text search. Text search is very useful for you want to implement search, and you can construct queries and perform queries. There's not much in text. Like and I like. I like.
One thing that I've seen that's not necessarily like that crazy, but a little bit hard to translate is there are some SQL queries that use like an inline query to be a value, as in like in an expression.
Yes.
And you can't do that in Squeal.
Well, you can do it in some ways, and you can't do it in other ways, because there's sort of ill-defined behavior when you do that in certain cases, and those certain cases are not allowed in Squeal. But you can do it as subqueries. So let's talk about subqueries, and maybe this will cover the case you're interested in, and maybe it won't. But here's an expression subquery. So you can use sub all or sub any. And so this query gets turned into a condition, which is often what you're doing with when you include a query as an expression. So for instance, you could say sub all true, use the equals operator, some query here, and it would say true is equal to all, and it embeds the query in there. That's one way of embedding queries as expressions. but it was a good question. And yeah, it doesn't cover all possibilities of using queries as expressions.
That brings up a question.
Yeah.
Which is, like, you gave us an example of something that is valid SQL, but is invalid Squeal. And the question is essentially, is Squeal trying to present a subset of Postgres, which is safe, as you said, like it sort of like forbids that case because it's ill-defined behavior, or is it trying to just embed Postgres?
It's just trying to embed Postgres, but obviously Postgres is huge, and I don't like put a high value on necessarily embedding pieces that I don't think I like for that case. Well, I haven't even thought about it that much, to be honest, how to like generally embed a query as an expression, but I know that it does lead to some inconsistencies. But yeah, I just haven't really thought about how to do that.
Okay, yeah, that was just I honestly wouldn't mind either way. Part of me likes that it doesn't include that because like it's not really well defined if there's more than one result to the query in most cases.
Yeah, it would be like the first thing, or it would be null if the query is empty.
Right. Yeah, I just had a lot of trouble like translating queries from SQL to Squeal that use that. I had to end up like I basically just used a subquery. Yeah. Oh, and then I think common is the thing that is one thing you haven't talked about. Oh no, you did talk about that the other day.
Common. We can talk about common and with statements.
Oh yeah, with statements are a thing. Done.
So yeah, we can talk about with statements. So we have a class for that because both manipulations and queries support using with. And so with says, give me a path of common table expressions and a statement. So this common table expressions builds you up from with 0 to with 1. And then if you give me a statement that starts with 1, it'll give me a statement that starts with 0. So this is sort of contravariant if you think about it that way. But what is a path? A path is, we talked about this before when we talked about migrations. So it's like a list. So you have a list of common table expressions. And how do you generate a common table expression? Well, common table expressions have an aliasable instance. So you just do them by saying you give the statement as its name. And so that's the same thing as you do in with statements in SQL. You say with statement as name other statement, right? Except it's not quite like that in SQL because the name, you actually say the name as the query. So it's backwards from how it usually is. But in Squeal, we just do it the same way as usual with the as, with the name on the right. So you can say with query as name, query that can now depend on that common table expression. And the way you can call a common table expression is you have a from clause that says common. So if that common table expression is in scope, then you can call it common. You can rename it if you like, and that'll give you a new scope to call expressions from. So going back to with, there's also with recursive, which only works for queries, but lets you do things like, what is this? This is like the sum. This returns a rolling sum, I think. 1, 2. Is this maybe a Fibonacci sequence? I don't know. So you can do with recursive also. And with is kind of another interesting thing about with queries is in some ways they're the opposite of joins. So if we look in this little tutorial here, when we get users, we have two tables, a user table and an email table that we're joining together using using the foreign key. And in order to invert that, right, this is one statement. Instead of getting back the stuff from the user's table separately from the stuff from the emails table and then somehow reconstructing it, we just get it back in one statement. And the inverse of that is to insert that information in one statement. And to do that, we use a with. So here we're going to say with u is u, e. U is going to be inserted into users. Values the default for the ID, but we're going to need to know what that ID is. So we're going to return it. And we're going to set the parameter as the name. So that's the parameter from the user, the name. And then we're going to return the ID and the second parameter as email. So now we have the foreign key and the email that we can insert into the next table if we call on you, we can say insert into emails, select default as the ID for the emails table, and then u is our common table expression, so we can look for u.id as our user ID that we got, remember, from returning, and u.email as email, and remember we got email from the second parameter of our user. So with is in some ways the inverse of inner join. In this case, the way that we're using it here, obviously it's more general than that.
I have another question about that. Like, let's say I want to insert a whole bunch of different records. Is there a way to
a whole bunch of what?
A whole bunch of records in a with, like in a big path. How would I do that? I haven't been able to get that to type check.
It's too general a question for me. I would have to look at a specific example.
Yeah, like let's say I have like a whole bunch of users and I want to stick them all in that with that you just showed me.
Well, it's already a statement, so I can insert as many users as I like. And in fact, that's what we're doing. We're inserting 3 users here. So the way we do that is we do execute prepared insert user on all the users. And execute prepared prepares my insert statement and then takes my list of users and runs the prepared statement on each one and then deallocates the prepared statement.
Right. So imagine if users, like imagine if user was a table that had like some normalized like list or set of things that I needed to insert before I inserted like the email or something. Sort of my question being like, can I use one with statement to insert a bunch of things in a sort of non-constant size path? That's the main question, is like, can I have non-constant size paths easily, or will that not be able to type check?
I mean, I haven't even tried that. I don't know like whether type checking or just SQL being able to do that in one statement is possible. Do you know that you can write a SQL statement that'll do that in one statement?
I don't know that. No.
Yeah.
My understanding is that you can write nested withs though, so I don't know why the number.
Oh yeah, you sure can, and that's no problem. And you don't even need to nest them. You can just make it a path of common table expressions. But it's just a question of the logic. Like if you're inserting multiple things, right? You have a list in your user, and you're like, hey, I want to insert all of them as separate rows. I wouldn't necessarily know how to write that in SQL. So this with example works out pretty well because it's pretty simple, to be honest. I don't know how simple it would be if it was like has to touch multiple tables and the tables are not sort of in one-to-one correspondence where like they are here.
Right. Okay. But that's so the answer is that you do not you've not had experience with that. That's fine. Okay.
No.
I've been using some really nice things that you offer in definition, because like in definition, it's a category. So I can like fold R with composition over a list of definitions and get a massive migration that inserts a whole bunch of things. And I was hoping to be able to use like with statements. So that's why I asked.
Yeah. With isn't quite as composable as a category would be, but yeah, that would be interesting to explore what kind of structure you can get out of it. Like, so because I showed you here, it's sort of like a contravariant functor. If you want to try to analyze what it is compositionally, right? Because here we go from with 0 to with 1, right? We start with a smaller context and end up with a bigger context. And then we have a statement which depends on the bigger context, and we output a statement which depends on the smaller context.
Right.
And so you could say, I mean, if you want to know what the sort of the law is for this with, it would be something like, if I say with C1, C2, or even if I say, yeah, the law should be something like, let's say our statement, this should be equal to with C1 something like that should be holding true. But these common table expressions, they don't quite form a category, but the paths over them form a category. So this is a category. So if you're interested in using fold, you might fold it here. And path is in fact the free category.
Right. The reason that it doesn't type check is because it's a path that augments the context at every given spot, and you can't you sort of can't forget about things in the with, and so you need to generate fresh variables, and you can't do that programmatically because they're symbols.
No. Yeah.
Can't you append symbols at the type level? You could make a longer and longer identifier, like A, and so on.
Yeah, you can. I'm just not sure how to then sort of. No, maybe that would just work. But I guess I was using foldar before, so I was expecting the actual arrows to be what's it called? Like endofunctions, endomorphisms, but now they're not. So I guess I'll just have to use a hand-rolled thing.
Well, if you really want paths, you can't fold them with fold R, but you can fold them with. Hold on. You can fold them with Q fold map.
You have another one called qfold R below. What would you suggest? Qfold map instead of fold R, instead of qfold R, instead of fold R? Is the qfold map better?
Well, it might work. I mean, it'll definitely work on a. So if you have a common table expression from Y to Z, and then you have a path of common table expressions. I mean, I don't know what it would mean, but you can play around with it. this C should be path. And here's an example. If I have a path of what qfold R is doing to my path.
Yeah, that does look like fold R.
Mm-hmm. But maybe that's not what we want, because we want to actually construct a path. We don't want to destruct a path like what is happening in a fold.
Yeah, you want a Q fold R where C and P are the free category.
Well, you want C to be free, to be path, and you want Q to also be path of something, right?
Right. Sorry, not P, Q. Yeah.
Yes, that would make sense.
Okay, so now I understand why you suggest map. But now I don't understand why you want fold map. Like if you want to go from a path to a path, it sounds like the indexed equivalent of map. Do you have that? QMap, there you go.
It's not necessarily about the folding part. It's like I did know about qfold R and qfold map, but it's about the building part. Yeah. Which is the thing that I think Sam's suggestion might work for, is like generating a bunch of dummy names to bind my intermediate inserts to.
Mm.
Oh, so you're starting from a list, like a Haskell list, that, and not from the indexed path that is more complicated. So you could write a fold R if the resulting path was always from the same two indices, but now you do want to make the index bigger and bigger. So yeah, I think you need to write a custom function. I don't think neither QMap or any of the things we see here would work, because your input is not a path, it's a list.
And I just want to say that understanding what this is talking about is not necessary for writing queries in Squeal.
Though it is convenient, I'll admit. Especially for definition.
Definition is just a category, so that one's nice and easy, right?
Yes.
So we got category, and we can lift manipulations to definitions, in which case they go from the database to itself, right? So if all you're doing is like adding data in your manipulations, then you're not actually changing the schema at all. And so this is an endomorphism. So is that what you're talking about?
Yeah, that's what I was talking about. I don't use qfold R or anything. I just use fold R, and I could actually use fold map because endomorphisms are just a monoid. So,
is that true that endomorphisms in a category in Haskell form a monoid?
oh, maybe not. I think you have to like wrap them or something.
Yeah, you probably have to wrap them. But then you could put them all in the list and turn that list into a definition.
Yeah, we have this like 3,000 line migration in Attack Designer that does that with the MITRE attack framework.
Neat. Does anybody else want to maybe teach the next class, or I don't know, we're kind of running low on material. What do you guys want to do from here on out?
I think that in the same way that Haskell beginners has evolved from some lectures by people who know what they're talking about to presentations by beginners who are struggling, but struggling in public with peers is more motivating than struggling alone. Maybe, yeah, in the future, those of us who, like me, want to learn but don't get a lot of opportunity to write some Squeal could be given an exercise and struggle with exercises in front of everyone.
Sure.
Do you have a list of exercises?
I don't have a list of exercises, but you had a list of exercises, didn't you? You said you were working on exercises from...
Oh, I did. That's true.
I also have some. I had some... there's a website with a bunch of exercises that I translated like a few sets of into Squeal.
Okay. So maybe next time let's work on those exercises, and we can start from. You can review the ones that you did, and we can start where you ended up.
I didn't go very far, so there's not much to review.
Okay, that's not
great.
a problem.
Yeah, we can start from where I stopped.
Okay. Then maybe I can correct some of the misconceptions of that blog author.
I did not read the part of the blog post where it talked about Squeal, only the part where it describes the table and what the queries were.
Okay, cool. All right, so let's end there. Thanks, guys.
Thank you.
Bye-bye.
Thanks, bye.